You're welcome. In this video, we are going to take a look at compound inequalities, particularly those that are and inequalities. So we previously looked at or inequalities. These are looking in like very similar as solving goes, but we're going to end up with the solution set that looks a little bit different. So let's look at these and inequalities. They can really be separated into two inequalities, but you can also leave it together because they can be true at the same time, unlike those or inequalities. So if we have an inequality like this, you're going to read it from left to right. -1 is less than x, which is less than 2. So just reading all the way across, your symbol should be facing the same direction, smallest to largest. Okay. So this graph would look just like this, that our values that are included here are between -1 and 2, not including that -1 or +2. If we had an or equals 2 on one of these, that would just change our graph by filling in that -1 would also be a solution to this inequality. All right, so how we're going to solve is we're going to apply our inverse operations in reverse order, just like we've been doing to solve, but to each piece of the inequality. So this inequality has 1, 2, 3 pieces. So rather than thinking the two sides of your equation or two sides of your inequality, you have 3 pieces here that you need to do those inverse operations to in order to isolate your variable. The solution set will be between the two values and may or may not include those values as well. So we end up with this bar looking thing rather than those arrows going away from each other like we had in our or inequalities. So let's look at some inequalities here. So we're going to solve the following and graph their solution sets. So I'm going to still be focused on my variable. So I'm still looking here at this n and say, what do I need to do to get that n by itself? But I have 3 things that I need to do that to. So we're still using our inverse operations in reverse order. So here we would add 5 first, but then I need to add 5 here and add 5 here. So now I have 6 is less than or equal to 2n is less than or equal to 12. Okay, then I'm looking at my variables, say what do I need to do to isolate that variable? And here we're dividing by 2. We're dividing, so we want to keep in mind, do I need to do anything with my symbol? I'm dividing by a positive number, so we're okay. So we get 3 is less than or equal to n, which is less than or equal to 6. Okay, now that the variable is isolated, we're looking at our number line. We know we need to have 3, 4, 5, 6 included, and fill in our number line on either side so that you know where you're at. Okay, 3 is an or equal to, so n could be 3. 6 is also an or equal to, and then we're looking at all of those values in between. So if you look at either side of your inequality, these values here are all greater than 3, right? Your variable there is the larger thing. But these values here are all also less than 6, right? 4 is less than 6, 5 is less than 6, 4.2 is less than 6, 3.5 is greater than 3. So we have all of those values between 3 and 6, including 3 and including 6. Okay, let's take a look at one more example here together. Keeping in mind we have those 3 separate places. We're trying to isolate our variable, so our goal here is to get this x by itself. So we're using our inverse operations in reverse order. So the first thing we need to undo is this subtracting 1. So we're going to add 1 to all 3 parts of our inequality. 6 is less than 3x, which is less than or equal to 18. Okay, now we have 3 times x. Inverse operation of multiplication is division. We're dividing or multiplying, so I'm thinking, do I need to do anything with my inequality symbols? In this case, no, because we're dividing by a positive. So we get 2 is less than x, which is less than or equal to 6. Okay, so again, we know we need to have 2, 3, 4, 5, and 6. Fill in your number line from there. Ended up with the same number line. Okay, we're not going to include 2. We are going to include 6. and it's all the values between 2 and 6. Okay, not filling in 2 because we're just greater than 2, and are going to include 6 because we're greater than or equal to. Check to see if makes sense. Is 2 less than 4? Yes. Is 4 less than or equal to 6? Yes. Okay. So let's look at going the other direction. So we have an inequality here. Let's write the inequality for the graph. So anytime we have a bar where it's connected, that we can write as one inequality. If we have two separate things, these things and these things can't happen at the same time. Those are our OR inequalities. We have to write those separately. So if we have a bar, we're just going to start with the smallest thing, the furthest thing left. -8. Decide, is it equal to? Nope, it's just less than our variable, which is less than, not equal to, 2. Okay, so we're just finding what is the furthest left, what is the furthest right, and the thing that we want, whatever our variable is, has to be between those things. Okay, here we can't write it all as one because you can't simultaneously be over here and over here at the same time. So we're going to start with one of them and say, okay, how do these values over here relate to -2? They're all smaller than, further left on the number line than -2. So our variable, pick any variable you want, k, has to be less than -2, or k has to be greater than 5. And all these values over here are smaller than -2. All of these values over here are bigger than 5. You can't be smaller than -2 and bigger than 5 at the same time, so we're using that OR inequality. One bar here, so we can use our AND. So we're just going to start on the left. +1. It's filled in, so it's less than or equal to our variable, which is less than or equal to the larger thing. All of these values here that are shaded in are between 1 and 4. So our variable is bigger than 1, but smaller than 4. Okay, again, a bar, so we can write it all together. Start on the smallest on the left, 3. Just less than our variable, p, which is less than 7. And all of these values in here are bigger than 3, and all of these values in here are also smaller than 7. They're sandwiched in there. Not a sandwich, can't be those simultaneously, so we're going to have to write two separate inequalities and use our OR. Pick a variable. Let's do n. N here has to be less than 2. All of these values over here are smaller than 2. Or n is greater than 6. So we're either less than 2 or greater than 6. We can't be those things simultaneously, so it's an OR inequality. Okay, let's look at one more here. Solving. We have this beautiful thing, compound inequality. 3 pieces. We are going to look at putting those 3 pieces together. So keep in mind, we're going to do our inverse operations in reverse order. So we're looking at -2x plus 1. Our goal is to get that -2x. Sorry, I'm getting a cleaner one here. That -2x, the x part by itself. A little easier to see. So we're going to use our inverse operations, reverse order still. So we're going to go here. Okay, here we have multiplication, addition. We would multiply, then add. So we're going to undo the addition first and making sure we do it to all parts of our inequality. -4 is greater than -2x, which is greater than or equal to 3. Okay, trying to get that x by itself. So we're going to divide. So we should have a little red flag going up here. I'm dividing by a negative. Alarm, alarm, alarm. Flip your sign. -4 divided by -2 is +2, which is x less than or equal to -3/2. So let's take a quick look at this and see what we think. Okay, if we do that, can something be greater than 2 and less than -3/2. So if you're thinking on your number line, we're here at -2 and over here at 3/2. Can I be over here and over here at the same time? Definitely not possible. So we ended up with this solution here that's telling us this is happening, but that's not possible for those things to happen at the same time. So what we're going to say in this case is that there is no solution. There is nothing that can make both of those things true at the same time. Okay, last thing, we're just going to look at a quick thing. If we have an or, right, we're solving these individually. So if I'm going to solve this one, I'm dividing by -2. I'm not doing anything to this guy, so this guy's still going to stay exactly the same. This is where now x is less than -3. So this guy here, I didn't do any dividing with that inequality. So even though it's part of my compound inequality, you're only going to flip the inequality symbol where you're dividing by or multiplying by a negative number. So that is all for this lesson. Thank you so much for watching.